Hi students, welcome to today's class. So in this video, I am going to explain a new chapter, that is a pair of straight lines. So this chapter is a very important for your JEE mains examination, which is going to commence in January 2023. Okay. So those who are perfect in straight lines chapter and the concepts and formulas, definitions, straight lines, they are they can easily understand this chapter, pair of straight lines. Okay now. So from this pair of straight lines and straight lines together, so we are getting a question in the JEE mains examination. This chapter is not only useful directly this chapter, so indirectly these concepts are very much useful in the parabola, hyperbola and ellipse, and also in the calculus and algebra part also these pair of straight lines concepts are very useful. So without wasting your valuable time, so let me start our class. Okay. Now pair of straight lines, pair means two straight lines. So we are all now going to discuss about the two straight lines. So what is the combined equation of those two straight lines? What is the angle between them? And what is the condition if those two lines are parallel, perpendicular, coincide? Okay. So and what is the angle bisector? All those things. If two lines and another one line, if they form the equilateral triangle, right angle triangle, what are the conditions? All those things we will discuss in our class. Okay now, right. Now first of all, pair of straight lines. So straight line means we know the general form of the straight line. So what is the general form of the straight lines? That is equal to ax plus by plus c is equal to 0, where a, b, c belongs to real numbers and both a and b does not simultaneously equal to 0. Okay now, that we know. Now we are going to discuss if there are two straight lines are there. So there are two straight lines are there. So one is a1x plus b1y plus c1 is equal to 0. Another one is a2x plus b2y plus c2 is equal to 0. There are two straight lines are there. They may be intersecting lines, they may be parallel lines, they may be coincidence, whatever may be that. Now I want to find out the combined equation of the pair of straight lines. Combined equation. So individual equation is a1x plus b1y plus c1 is equal to 0. Here also a2x plus beta. Individual equations we know their slope, inclination. So all those things we learned in the previous chapter. Now we are going to discuss what is the combined equation. So we want a equation, a general equation which represents both the pair of lines. That means what? That equation should satisfy the each and every point on both the lines. So that equation we want to solve, we want to get it. So to make you understand that, let us take one example. For example, if there is an equation 2x plus y minus 3 is equal to 0. For suppose 2x plus y minus 3 is equal to 0. Let there be another equation of the line, so that is equal to x plus y minus 4 is equal to 0. There are two lines are there. The equation of the first line is 2x plus y minus 3 is equal to 0. The equation of the second line is x plus y minus 4 is equal to 0. Let us call it as the first line is L1 and the second line is L2 for our convenient sake. Now I want a combined equation of these two lines. Then what shall we do? What shall we do? Shall we add these two equations? Shall we subtract one equation from another equation? Shall we multiply these two equations, or shall we divide one equation with another equation? Okay now. So let us check. For example, first if you add both the equations, if you add the equations, you will get a common equation. Let us check that equation will satisfy the given conditions or not. For example, if you add the two lines 2x plus y minus 3 plus x plus y minus 4 is equal to 0. So I have got a combined equation, that is 3x plus 2y minus 7 is equal to 0. Is this line satisfies all the points on these lines? Let us check. So let us take a one point on the first line as let us take the point, it is some 1 comma 2. So 2 ones are 2. So 1 comma 1. So let us take a point as a 1 comma 1. 2 into 1 plus 1. 2 plus 1 3. 3 minus 3 0. So 1 comma 1 satisfies the first line. Let us take another line. So this is a 1 comma 3. 1 plus 3 4. 4 minus 4 is equal to 0. The second line satisfies the 1 comma 3 satisfies the second line. Now when you are saying this is a combined equation of both the lines, so both this point, this line, both these points should satisfy this equation. Let us check it. So first you substitute 1 comma 1 here. So if you substitute 1 comma 1, so 3 plus 2 5, 5 minus 7 is equal to minus 2, which is not equal to 0. So that means if you add these two equations, that does not satisfies the given condition. That is the condition means what? Every point on the pair of lines should satisfy the given. Same applies for if you subtract these two equations L1 minus L2. So if you subtract, what happens to here? 2x minus x. So this is a plus y minus y is also get cancelled. Minus 3 plus 4, that is equal to plus 1 is equal to 0. So x plus 1 is equal to 0. If you substitute x is equal to 1 here, 1 plus 1 is equal to 0 now. So this also fails. So this subtraction of the lines is also, subtraction of the equations of the lines is also failed. So next we will take, let us multiply the equations. What are the equations? L1 into L2 is equal to 0. Let us multiply. What is the first equation? So this is equal to 2x plus y minus 3. What is the second equation? X plus y minus 4 is equal to 0. Now what I am doing is, now I multiplied both the equations. Let us check each and every point on this line will satisfy this equation or not. Okay, let us check. So first take, let us consider 1 comma 1. So substitute here 1 comma 1. So if you substitute here 2 into 1, so 2 plus 1 minus 3. So this is 2 plus 1 minus 4 is equal to 0. Yes, why? Because 2 plus 1 3, 3 minus 3, 0 into a finite quantity, that is equal to 0. Yes, it is satisfied. Let us take another point 1 comma 3, which is on the second line. Substitute here 1 comma 3. So if you substitute here 1 comma 3, 2 into 1, 2 plus 3 minus 3, 1 plus 3 minus 4 is equal to 0. So plus 3 minus 3 cancel, it is a 2. Here 1 plus 3, 4, 4 minus 4 is equal to 0. That means, what do you observe from this? The product of these two lines, satisfies the given condition. What the condition means here? What? Each and every line, each and every point should satisfy the equation. So that means this line equation satisfies all the conditions. Let us substitute, let us check the division. That means what? Let us divide the first equation with the second equation. Let us check what happens. What is the first equation? 2x plus y minus 3 upon second equation x plus y minus 4 is equal to 0. Let us substitute first 1 comma 1 here. So if you substitute 1 comma 1 here, 2 into 1 plus 1, that is equal to 2 plus 1 minus 3 by, so here 1 plus 1 minus 4. So is it equal to 0? Yes. Why? Because 2 plus 1 is 3, 3 minus 3 is 0, 0 by minus 2. 0 by minus 2, here minus 2 denominator is a finite quantity. Therefore, 0 by minus 2 is equal to 0. Yes, it is satisfying. But what about second point? So take the second point 1 comma 3, substitute here 2 into 1, 2 plus 3 minus 3 upon. So 1 plus 3 minus 4 is equal to 0. No, it is not at all 0. Why? Because here the denominator will become 0. So division with the denominator is not possible in real number. That is not defined. That's why division is also not possible. division is also not possible. So on the whole, from this discussion, what we can say, it means, so if given a two lines, two equations of two lines, the product of their equations, only satisfies all the points on both the lines at a time, okay na? So from this, so the product of these two lines, if you multiply these two lines, equations of the two lines, then that will give the combined equation of the two lines, okay na? So I hope that you understand this concept. So let us see that concepts, let us see the combined equation of the two lines in a general form, okay na? Dear students, here we will get two cases here. Here the first case is, let us take a coordinate system, so that is equal to x-axis and y-axis. The first case is, let us see that the two lines passes through the origin. So this is a first line and it is second line. The two lines passes through the origin. So this is a one set of equations we will get. The second one is the lines x-axis and y-axis, the set of lines which does not passes through origin. So they does not passes through origin. So this is one set. Here only two cases arises. One case is the lines passing through origin, their equation, the angle between them, if these two lines are coincide or perpendicular, then what are the conditions? So if these two lines are there, they are not passing through the origin, then what about their equation? First of all, what are the equations and what is the angle between them? If they are perpendicular, parallel, coincide, what is the condition between them? All those things that we are going to see, okay now. So the first thing is, if two lines are passes through origin, okay now, what is their combined equation? So to make you understand clearly, so let us take this first equation is some y is equal to 2x. Let us take a equation of the second line is y is equal to 3x. Let us take that, y is equal to 2x, y is equal to 3x. So this is a 2x and it is 2x. Y is equal to 3x, y is equal to 2x. There are two lines. We know that in the straight line chapter, the equations of the line passing through origin is y is equal to mx form. So I will write it as a 3x minus y is equal to 0. This is a 2x minus y is equal to 0. Now just now we explained that the combined equation, that means the product of these two lines will give the equations of the product, these two lines will give the combined equation. So let us multiply this. So this is equal to 3x minus y into 2x minus y is equal to 0. So multiply this. So this is equal to 6x square minus 3xy minus 2xy plus y square is equal to 0. So this is equal to 6x square minus 5xy plus y square is equal to 0. So this is called a homogeneous second degree equation. Homogeneous second degree equation in the variable xy. Okay, let us discuss this case in another video. Let us first concentrate on the pair of lines which passes through the origin. Okay now. So here what you observe here, x square is there, xy term is there, y square is there. Here degree 2, here degree 2, here degree 2. Okay now. So therefore this is called homogeneous second degree equation in the variables x and y. Okay now. So what is the general form? So general form is what? So this is a ax square plus 2hxy plus by square is equal to 0. So the general form is ax square plus 2hxy plus by square is equal to 0. Is all lines represents the pair of lines? No, there are conditions on a, h, b. There are conditions on a, h, b. Here a, h, b are set of real numbers. They belong to set of real numbers. So what are the conditions on a, h, b? So let us see that. Okay now. Welcome to this concept here. So here already we told that ax square plus 2hxy plus by square is equal to 0. So it represents a pair of straight line passing through origin. So when the two straight lines are passing through origin, these two lines are passing through origin. there will be only three cases arises. These two lines either coincide or distinct or perpendicular. Okay, either coincide or distinct. Coincide means what? For example, so this is coincide. So here two lines L1 and L2. So this is x-axis, y-axis. Both L1 and L2 coincide. Second one is distinct lines. Distinct lines means what here? So there are two different lines. We are getting two different lines. That is called distinct lines. Next case is what? Perpendicular. Perpendicular means what? So for example, if it is this is a one line passing through origin, another line is perpendicular to it. So this is a perpendicular line. So when there are two lines are there, there will be possibility cases of only three cases. One is first one, either two lines will coincide, not parallel. Here there won't be any question of parallel, only coincide. Why? Because both the lines should passes through origin. Second one is distinct lines. Third one is perpendicular lines. So the conditions, let us see that. So here already told that A, H, B are real numbers. A, H, B are real numbers. A, H, B belongs to real numbers. Okay now. Right. If H square is greater than AB, the two lines are distinct. So here H square is greater than AB. This is a condition. Next one, if H square is equal to AB, the lines are coincide. So this is the condition. H square is equal to AB. Two lines are condition. The next one more condition is also here. The condition is this, that is fourth one. If A plus B is equal to 0, the lines are perpendicular. That means this is the case. A plus B is equal to 0. A plus B is equal to 0. Then the two lines are perpendicular. If H square is greater than AB, the lines are distinct. If H square is equal to AB, the lines are coincides. If A plus B, that means the x square coefficient and y square coefficient, and their sum is equal to 0, the two lines are perpendicular to each other. But what about if H square is less than AB? So you will get imaginary lines. How we will get means we will see here. Okay, so we will see that next concept. So I hope that up to here you understand this concept. Now let us see that given two line equations, we know how to find out their combined equation. How to find out? Just multiplying those two equations. Okay, now if a combined equation of a pair of lines is given, how to separate them? How to factorize them? That is the main important concept. So if equation of separate lines, ax square plus 2hxy plus by square is equal to 0, it contains two lines. So if you want to find out the equations of the separate lines, that means if you want to separate them, so the equations are this: ax plus y into h plus root of h square minus ab. Second equation is ax plus y into h minus root of h square minus ab. Okay, na? So ax plus by is equal to 0, ax plus by is equal to 0. So these are the two equations which contains in this combined equation. Okay, na? See here, depending upon, see here, root of h square minus ab is there now. So depending upon this equation, this quantity h square minus ab quantity, all these all these conditions arise. If h square minus ab is greater than 0, so you will get two values here, therefore you will get two distinct lines. If h square is equal to ab, that means root of h square minus ab value will become 0. So this is ax plus hy, ax plus hy. So you will get coincident lines. If h square is less than ab, so here if h square is less than ab, so under square root you will get imaginary quantity. Imaginary number you will get. So in the square root there should not be any negative number, no. So that's why, so you will get imaginary numbers. So if a plus b is equal to 0, then the two lines will be perpendicular to each other. Okay, na? Right. I hope that you understand this concept. So let us go for next concept. Welcome to the next concept, that is slopes of the lines. What are the slopes of the lines? Let us see that. Let us see the two-dimensional coordinate system. So this is a x-axis and it is y-axis. So x-axis and y-axis. Okay. So let us take two lines which are passes through origin. So let us take this. So this is a first line, y is equal to m1x. Second one is y2 is equal to m2x. There are two lines are there where m1 and m2 are not equal to each other. There are two distinct lines, y is equal to m1x and y is equal to m2x. The slope of the first line is m1, the slope of the second line is m2. Okay now. So their combined equation is already it is given that what is the combined equation. So this is ax plus by, sorry, ax square plus 2hxy plus by square is equal to 0. Okay now. So what I am going to do is, so we know that general form is any line passing to general form is y is equal to mx. Therefore, m is equal to how much? Y by x. M is equal to how much? Y by x. So that's why multiply, divide this equation with x square. Let us see what happens. So this is a plus 2h into by x square, this by, so this is a y by x. So this is b into y by x whole square is equal to 0. So what I am doing here? So I am dividing with x square on both sides. See here, m is equal to y by x. That's why wherever m is there, substitute y by x. So you will get, so this is equal to bm square plus 2hm plus a is equal to 0. You got a quadratic equation in m. You got a quadratic equation in m. So bm square plus 2hm plus a is equal to 0. Where I have substituted y by x is equal to m, y by x is equal to m. So this is a quadratic equation here. So it will have a two roots, one is m1 and m2. So it will have two roots, m1 and m2. The first one is sum of the slopes m1 plus m2 is equal to, you know that in a quadratic equation x square plus 2hx plus b is equal x square plus, quadratic equation ax square plus bx plus c is equal to 0. It has two roots, alpha and beta. So what is the sum of the roots? Alpha plus beta is equal to minus b by a. Alpha into beta is equal to c by a. Understand this. So sum of the roots means what? Minus b by a, that is a minus 2h by b. Second one is product of the roots, m1 into m2 is equal to c by a, that is a by b. So these are the two relations we got. That means if m1 and m2 are the slopes of the lines represented by ax square plus 2hxy plus by square is equal to 0, then the sum of the slopes is equal to minus 2h by b, that is the roots of this quadratic equation, m1 and m2, product of the slopes is a by b. And the third one is, third one also you remember for your JEE mains point of view, that is m1 minus m2. Let us write that in the modulus. Why? Because we don't know which is one is greater, which one is lesser. To avoid the negativity, substitute m1 minus m2. So this m1 minus m2 is given by, so 2 root of h square minus ab by modulus of b. So 2 root of h square minus ab by modulus of ab. Sir, how you got this? Means very easy, very easy. So we can write it as a m1 minus m2 is equal to under square root of m1 plus m2 whole square minus 4 m1 m2. Substitute here, m1 plus m2 is equal to minus 2h by b, m1 m2 m2 is equal to a by b. Substitute and simplify, you will get 2 root of h square minus ab by modulus of b. Okay na? So this is the concept, that is, this is called sum of the slopes, product of the slopes, difference of the slopes. Okay na? I hope that you understand this concept. So let us go for next concept. So welcome to the next concept, that is angle between two lines. So angle between two lines already. So let us take a coordinate system, x-axis and y-axis, x-axis and y-axis. Let us take the two lines passes through origin. So this is a L1 and L2. Let theta be the acute angle between the two lines. Acute angle between the two lines. Let the combined equation of these two lines is ax square plus 2hxy plus by square is equal to 0. The combined equation of those two lines is ax square plus 2hxy plus by square is equal to 0. And one more thing is, let us say h square is greater than ab, so that those two lines will be distinct and there will be an angle between them. Otherwise, if h square is equal to ab, those two lines will be coincide, the angle will become 0. Okay. Now, if theta is the angle between them, then cos theta is equal to a plus b upon under square root of a minus b whole square plus 4h square. So, this is the formula to find the angle between them. So, let us learn tan theta formula also. So, this is tan theta is given by 2 root of h square minus ab by modulus of a plus b. 2 root of h square minus ab by modulus of a plus b. So, both are important. So, sin theta formula is also there. So, no need of that. So, if you know cos theta, we know how to find out sin theta. So, but tan theta formulas also, sometimes this formula is very, very useful. So, these are the two formulas we have, right. If the angle between them is, for example, here h square minus ab, first of all, if the angle between them is 0 degrees, then h square is equal to ab. That means if h square is equal to ab, total this will become 0. Therefore, tan theta is equal to 0 means theta is equal to 0. The second one is if the angle between them is 90 degrees, that is perpendicular. So, put here cos 90. Cos 90 is equal to how much? 0. This cross multiplication is also 0. So, modulus of a plus b is equal to 0. This implies a plus b is equal to 0. Okay, na? So, these are the two conditions that we will get from these two formulas. So, this is a cos theta formula. So, this is tan theta formula. Okay. So, I hope that you understand this concept. Okay, na? So, dear students, I hope that you enjoyed today's class. With some more topics, tomorrow's class I will start before you. So, until then, all the best.